Hello everyone, I am Tanuja. I am currently pursuing BTech final year in Electrical and Electronics Engineering at Tigala Krishna Reddy Engineering College. Today in this presentation, I am going to present my paper which is going to publish in 7th International Conference on Computing Methodologies and Communications. My paper is titled as 15 level inverter for standalone applications. ICC MC 140 is my paper ID. Coming to abstract, to consume medium level voltage and higher power nowadays, multi-level inverters are employed in many industries. The properties of multi-level inverter is same as inverter. Compensation of reactive power is primarily done by multi-level inverters. Generally, existing multi-level inverters are 5 level, 7 level, 9 level. In this paper, introducing a 15-level multi-level inverter with reducing switches analyzed for current, voltage and total harmonic distortion, that is THD. Analyzed and contrasted various types of multi-level inverter including diode clamped multi-level inverters, flying capacitor multi-level inverters, and cascade H-bridge multi-level inverters. Keywords used in this paper are inverters, multi-level inverters, pulse width modulation technique, and harmonics. Introduction. Inverters that convert direct current to alternating current, which we are used for domestical applications and many industrial applications, demand high voltages or power levels. So we are proposing the usage of multi-level inverters. Multi-level inverter architectures are particularly advantageous for high-level power equipments because they may reduce load voltage where harmonics presented by controlling between different levels of voltage and can function at high DC bus voltage. In series connection, switching devices are connected. Multi-level inverters is a concept that begins with two levels and allows levels to be raised by feeding new sources. Multi-level inverters produces a staircase waveform from many DC sources. The staircase waveform's characteristics causes a decrease in total harmonic distortion, that is THD, and filter size. There are three types of multi-level inverters: diode clamped multi-level inverter, flying capacitor multi-level inverter, cascade H-bridge multi-level inverter. Different multi-level inverters. First one, diode clamped multi-level inverter. The figure shows 5-level diode clamped multi-level inverter. The fundamental idea behind these diode clamped multi-level inverter is to use diodes to provide a series connected capacitor bank with several voltage levels via various phases. Voltage is clamped to the diodes. The DC input voltage is divided in half by the output voltage. Due to the basic frequency being utilized by all switching devices, it has a high efficiency. It is straightforward regenerative power transmission system approach. These type of inverter used in motor drives with variable speeds and DC and AC transmission lines with a high voltage. The capacitor voltage EM equal to VDC by M minus 1, where EM is the capacitor voltage, VDC is the DC voltage, M minus 1 is the number of capacitors. Second one, flying capacitor multi-level inverter. The figure shows 5-level flying capacitor multi-level inverter. These flying capacitor multi-layer inverters core concept is to utilize capacitors. It is made up of series connected switching cells with capacitor clamps. The capacitors deliver constrained voltage to electrical equipment. Compared to a diode clamped inverter, these inverter switches state similarly. Clamping diodes are not necessary. for this specific type of multi-layer inverter. This type of inverter is used for applications for both AC to DC and DC to AC conversion. Third one is the cascade H-bridge multi-level inverter. The figure shows the multi-level cascade single-phase H-bridge inverter. Switches and capacitors are used in cascade H-bridge multi-level inverter, which requires fewer parts per level. Power can be easily scaled up with this topology, which comprises several power conversion cells. A pair of capacitors and switches form an H-bridge, each of which has a unique input DC voltage. There are three voltages: 0, positive DC voltage, and negative DC voltage can be produced by one of the H-bridge cells that makes up the device. This type of inverter is used in motor drives, active filters, and electrical vehicle drives. Coming to the proposed topology, the figure shows 15-level inverter. It consists of 7 switches, that is M1 to M7, and 3 diodes D1 to D2, D3 are connected in series across 3 capacitors C1, C2, and C3. Each MOSFET is connected to the pulse width modulation. For M1, M2, and M3, a DC supply is connected in series. In between M4, M5, and M6, M7, resistance is jointed. 15-level output voltage waveform generation. Pulse width modulation is used to turn on and off the switches M1, M2, and M3. Switches M4, M7, and M5 are switched on to achieve reverse polarity, while switches M5 and M6 are turned off for a off cycle. Switches M5 and M6 are activated during the second off cycle, and switch M4 and M7 are deactivated. It is not recommended to turn on all the switches at once, that is M4, M7, M5, and M6. Coming to control scheme, to control the multi-level inverter, we require multi-carrier pulse width modulation. The level shifted pulse width modulation technique waveforms is displayed in the diagram above. The carriers are positioned vertically in the figure shown. Comparison. Comparison of various types of inverters like 5-level diode clamped inverter, 5-level flying capacitor inverter, and single-phase cascade H-bridge inverter compared with the number of switches and capacitors, diodes, and DC source. Coming to simulation results, figure 1 shows the output current of the 15-level inverter. Figure 2 shows the output voltage of the 15-level inverter. Figure 3 shows the total harmonic distortion, that is THD waveform of 15-level inverter. The minimum total harmonic distortion value is 9.88%. Conclusion. This paper presents the 15-level inverter with reducing switches. The different multi-carrier pulse width modulation technique are analyzed for voltage, current, and minimum total harmonic distortion of 9.88%. The load current and voltage is obtained in the form of a staircase. Comparative analysis is done between various multi-level inverters, including diode clamped multi-level inverter, flying capacitor multi-level inverter, and cascade H-bridge multi-level inverter. Thank you.